Hello everyone. Today I am going to be taking up a question on constraint relation, more specifically the Pulley constraint. I am going to be elucidating this further with the solution of this problem along with the explanation of the micro concept that we are going to be using. So for those of you who are already aware of the micro concept can skip that portion of the video solution. So let us look at the formal the language of this question. Prove that the acceleration of pulley 1, 2 and 3 follow the relation a1 plus a2 plus 2a3 is equal to 0. Now observe that we have not been given the direction of a1, a2 and a3. So what I'm going to do is I'm going to assume the direction of 1, 2 and 3, that is the three pulleys, to be upwards. So a1 is going to be like this and a2 is going to be like this and the a3 is also going to be upwards. Now if my assumption is correct, a1, a2 and a3 are going to come out to be positive. But if it is wrong, then it is going to come out to be negative. Now, throughout the length of this video, I have taken the upwards direction to be the positive direction and the downwards direction to be negative. This is true for the velocity as well as the acceleration. So this is the coordinates system that I have specified. So before I continue with the solution to this question, let us understand the micro concept that is involved to solve such kind of Pulley constraint. So there are three type of pulley arrangements that you need to analyze throughout your preparation for your competitive examination. So let us look at the type 1 pulley. So in this type, the top part is fixed. Okay, so this length is fixed. Now also I need you guys to remember that the fundamental concept behind the three arrangement is that we have to take the string length to be constant. It can't be changed. It is inextensible string. Okay, so that is the fundamental concept behind all three type of pulleys. So let us look at the first pulley. The top part is fixed. So if I move this part by a distance of x, this means this would there would be an extra x portion length here which would go downwards, right? So if this part is fixed, then if this part moves x distance, the other part will also move x distance. This implies that if the velocity of this part of the pulley is v, the velocity of the other part is also going to be v, and simultaneously we can also differentiate it and say the acceleration of this part is a, also the acceleration of this part is a, right? So this was the type 1 pulley. Now the second type of arrangement of pulley is if I fix this part of the pulley. Okay, so what is going to happen? Now assume once I move, this part is absolutely fixed. Once I move this center part of the pulley by a distance of x. So in this kind of arrangement, there is going to be an extra length x over here and also an extra length x over here. Since this part of the pulley is fixed, it will not contribute to this extra length. So this part of the string has to move a distance of 2x. So this moves a distance of x while this moves a distance of 2x, which in turn implies that if the velocity of this part of the string, which is this part of the string, is v, then the velocity of this part of the string is going to be 2v. Simultaneously, we can differentiate and say a, this should be comparable to a, and this will be 2a. Okay, so this was the type 2 pulley. Now the type 3 pulley is rather very important because a lot of difficult questions are formed based on this concept only. So let us assume the top part of the pulley, it moves by a distance of x, for example. And let's say that this part of the pulley moves by a distance of x1 and this part of the pulley moves by a distance of x2. Now you can say that there is going to be an extra space. This moves x1 and this moves x2. So there is going to be an extra x1 space over here and an extra x2 space over here. So the total extra space is going to be x1 plus x2. But in reality, this part moves always half of these parts combined. So I can say that x is equal to x1 plus x2 divided by 2. This is the general formula. This is a very standard formula that you guys need to keep in mind. So I can also say that the velocity, I can differentiate it once and I can use a similar result for the velocity as well as the acceleration by differentiating it twice. Now coming back to the question, now what can we do over here? So first of all, let us say the velocity of this part is V3, that is upwards. The velocity of this part of the pulley is V2, that is upwards, and the velocity of this part is V1, that is also upwards. Okay, so what I can say is, if this part, let us also assume that the velocity of this part is V. Okay, so if this part is V2, we can also say, since this is connected with this thread over here, the velocity of this part is also going to be V2, right? So in this part, I am just assuming this is the third type of pulley over here. So what I'm gonna do is, I can say let the velocity of this part be something I do not know yet. So V plus this part over here divided by 2 is nothing but V2. So the velocity of this part is going to be nothing but 2V2 minus V, right? So let me write it down nicely. So what I can see over here is, if the velocity of this part is V, so this part is also going to be V. Now, since this is fixed end over here, this is fixed over here, so the velocity of this part is going to be V. So the thread does not slack on this side. This is the second type of pulley. This is the first type of pulley. Okay, so the velocity of this part is V. The velocity of this part is 2V2 minus V, pardon me. And now I'm going to use the third formula on pulley 1 once again to find this part. So what I can say is 2V2 minus V is equal to, let's say the velocity is this, this plus, since I have this is going in a downward direction, I'm going to take this to be minus V upon 2, right? So this is going to be 4V2 minus 2V is equal to minus V. So this is going to be 4V2 minus V is equal to velocity of this part. So this is going to be nothing but 4V2 minus V, right? So since this is also the first kind of pulley, the velocity of this part is also going to be 4V2 minus V. Now observe, this is also going to be 4V2 minus V. Now observe, this part velocity is V2 and this is 4V2 minus V. Okay, I had assumed that the velocity of V3, this is V3. So actually V2 is equal to V3, and since this is in the downward direction, this will be nothing but minus times of 4V2 minus V. Okay, so V2 is equal to minus 4V2 plus V. This implies that V2 is equal to V by 5, right? Now also need you to observe that V2 and V3 are equal to each other. So V3 is also equal to V by 5. Okay, so for V1, so V1 is nothing, this is V1, and V1 is nothing but 2V2 minus V. So V1 is equal to 2V2. V2 is nothing but V by 5. 2V by 5 minus V, that is equal to minus 3V by 5. Right. So what I can do now is, I can say V1 plus V2 plus 2V3 is equal to minus 3V by 5 plus V by 5 plus 2 into V by 5, and that is equal to 0. Okay, so I can say V1 plus V2 plus 2V3 is equal to 0. So once I differentiate this with respect to time, I am going to be left with nothing but A1 plus A2 plus 2A3 is equal to 0. And that is the required proof that we had to do. So that's it for this video. I hope you understood the concept.